Hello everyone, I'm Mary Swarnalatha, working as an assistant professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the monotonic transformation of single random variable. So, what is a transformation of a random variable? So, transforming is nothing but changing the variable from one form to the other form. There is nothing but transformation. So, for example, if we are having a system, for this system, the input random variable, let us say x. So by performing operation on this variable, nothing but transformation. Transformation nothing but performing the operation. So by performing the operation on this random variable, I'm going to get a new random variable y. Then how do you represent y equals to t of x? So t of x, what does it represent? Transforming the random variable x into a new random variable y. That is nothing but transformation of random variable. For example, the random variable x is having some values like 5 and 6. Let us say it is a discrete random variable and I am transforming this random variable such that I am squaring the values which I have in the random variable x. Then what are the y values here? So 5 square nothing but 25 and 6 square nothing but 36. It means I am transforming this random variable into a new random variable by performing the operation. What is the operation here I am performing? I am squaring the random variable. By squaring the values in the random variable x, I am going to get a new random variable y. That is nothing but transformation or the operation. Now the same concept you apply to the random variable, you can apply to the system also. So, and if the distribution function of the random variable x is, let us say, fx of x and the corresponding density function is fx of x. So, we know that the distribution function has been represented by the capital letter f and the density function has been represented by the small f. Now, after transforming, I know the density function and I know the distribution function of the random variable x and applying to the system so that after transforming, I am getting a new random variable y. Now I want to calculate the distribution function of the random variable y and the density function of the transformed random variable y. Then we have to derive the distribution function and the density function of the transformed random variable if we know the distribution and density function of the original random variable x. Now here I am telling the transformation. So what is a transformation? So you have different types of transformation here in this, but you are studying only two types of transformation. One is what? Monotonic transformation, and the other type of transformation is what? Non-monotonic transformation. So what is monotonic transformation? So monotonic is nothing but mono is nothing but one. So non-mono is nothing but what? Many. So monotonic transformation nothing but will have one-to-one correspondings between the random variable x and the transformed random variable y. That is called as what? Monotonic transformation. So for example, if I have x is equals to, for example, if I have x is equals to some 1, 2, 3, 4 and I am taking y equals to, how we are getting the random variable y? By performing the operation on the random variable x. Let us say y is equals to, by multiplying the random variable x with 3, I got the new random variable x. Then what is the transformed random variable? 3, 6, 9 and 12. So here, if you observe here, the 1 is corresponding to here 3 and the 2 is transformed to the value 6 and 3 is transformed to the value 9 and 4 is transformed to the value 12. It means there is a one-to-one correspondence. This is called as what? Monotonic transformation. And in the monotonic, again you have the increasing, monotonically increasing and monotonically decreasing. In the later concepts, you'll see what is monotonically increasing and decreasing transformation. And the second type of transformation we are going to study is non-monotonic. Nothing but there is no one-to-one correspondence. You'll have one-to-many correspondence. For example, if I have a random variable x such that x is equals to -1, 0, 1, -2, like this. And I'm transforming this random variable x into a new random variable y by performing some operation. Here, what operation here I'm performing? Just I'm squaring the random variable x. Then what is y is equals to? So what is minus 1 square? Nothing but 1. And what is 0 square? Nothing but 0. Again, 1 square, nothing but 1 only. And what is minus 2 square? Nothing but 4. It means, if you observe here, I'm changing the random variable x into the random variable y by performing some operation. Nothing but here, I'm squaring the values in the original random variable x. So if you observe the correspondence or mapping between the original random variable and the transform random variable, what can you observe? So the minus 1 and 1 both are corresponding to a single value 1. And 0 is corresponding to 0 and minus is corresponding to the value 4 in the random variable, in the transform random variable y. It means both the minus 1 and 1 both are corresponding to a single value in the random variable y. Nothing but what? These are many values and this is a single value. Nothing but many to one correspondence. That type of transformation you are calling it as what? Non-monotonic transformation. Now what can you say the monotonic transformation? The monotonic transformation will have a one-to-one correspondence between the original random variable x and the transformed random variable y. And first, if you see here, monotonically increasing. When can you say that a function is monotonically increasing? You can say that if t of x1. So, what is y equals to t of x? Then, what is t of x1? Nothing but, it is a value in the random variable x, nothing but what? y1. A particular value of x is nothing but here x1. X may consist of like x1, x2 and so on. So, a particular value of the random variable x is called as what? Represented by small letters x. So, what is y1 equals to t of x1? And what is t of x2? Nothing but y2 is nothing but t of x2. So, if this y1 is less than y2, if x1 is less than x2, it means as the x value is increasing, what about the y value? It is also increasing. That's why it is called as what? Monotonically increasing. For example, here take this is x1 and this is x2. What are the corresponding here? The value of x1 is y1 and corresponding to the value of x2 is nothing but y2. So, here x1 is less than x2. What about y1? So, y1 is less than y2. So, y1 is less than y2. If x1 is less than x2, then it is called as what? Monotonically increasing transformation. For example, you are assuming that the function is continuous function. And there is a one-to-one. Since I'm saying here monotonic, there is a one-to-one correspondence only. Okay. Now, let us derive the distribution density function of the transformed random variable if you know the distribution density function of the original random variable x. Now, what is my x here? This is my original random variable. And what is my y here? Nothing but the transformed random variable by performing the operation. Here, what type of operation performing? Monotonically increasing. Therefore, what is my y equals to? So, y is equals to t of x. Now, if you see here, what is y1? Nothing but t of x1. By performing operation on x1, you are going to get the value of y1. And what is y2? By performing operation on x2, you are going to get y2. So, therefore, what is y1 equals to t of x1 and what is y2 equals to t of x2. Similarly, what is y0 is equals to, if you take any value in y, then what is y0 equals to t of x0. What is y0 represents? It is a particular value of the random variable y. And what is x0 represents? It represents a particular value of the random variable x0. Okay. Now, this x0 is transformed to a new value y0. That is the meaning of this. Y0 equals to what? T of x0. Now, if the distribution function of the random variable x is fx of x and the density function of the random variable let us denote by fx of x. So, this is called the distribution function and it is called as what? Density function. CDF is nothing but cumulative probability distribution function. Simply we'll call it as distribution function. And PDF is nothing but probability density function. And simply we'll call it as what? Density function. Now, so if you take any value, then what is y equals to t of x. Now, I am taking the distribution function of the random variable y, the transformed random variable. I want to calculate the distribution function of the transformed random variable y. So, how do you print the distribution function of the random variable y? Capital F. Distribution nothing but capital letter. So, capital F y of y is equals to what? From the definition of the cumulative probability distribution function. What is Fi of y is nothing but is a probability of the random variable y take such that less than equals to y, nothing but p of y less than equals to y naught. Okay, so what is Fy of y naught is nothing but what? The probability that the random variable y takes less than or equals to y naught. Similarly, if you take in general, this is a particular value. If you take in general any value, then what is Fy of y is equals to p of y less than equals to y. So, what is the probability that y less than equals to y? Nothing but probability that x less than equals to x. Is it right? How can you say that? For example, if you have the random variable x as, if I throw a die, what is the outcome? What is sample space for that? 1, 2, 3, 4, 5, 6. Here I am considering a discrete case, not understand clearly. So, this is the sample space when I throw a die. Then, I am transforming this y to the new random variable x as what? I am transforming this x into y. So, by performing some operation, let us say by squaring, I am turning into a new random variable y. Then, what is the new random variable y values? 1, 2 square nothing but 4, 3 square nothing but 9, 4 square is 16, 5 square is 25 and 6 square is 36. Now, what is the probability that x equals to 1? How many total values here? 6 values are there. And what is the probability that it is getting the number 1 and the die nothing but how many? The possibilities here? Only one possibility to get 1. Out of total, how many possibilities here? 6. So, number of favorable outcomes where total number of outcomes gives the probability. So, P of x equals to 1 is equals to what? 1 by 6. And what is P of x equals to 2? Nothing but 1 by P of x equals to 2. Nothing but what? 1 by 6. Now, what is P of x is less than or equals to 2? It's nothing but what you have to do? You have to take probability that x equals to 1 and the probability that x equals to 2. So, nothing but what is the probability that x equals to 1? 1 by 6. And what is the probability that x equals to 2? Nothing but 1 by 6, that is equals to what? 2 by 6. Okay. Now, so what is the probability that y equals to 1? Nothing but, see here, what is the probability of getting number y? 1. Nothing but the number of favorable outcomes are only 1 out of 6 outcomes. Therefore, probability equals to 1 by 6. Then what is the probability that y equals to 4? Nothing but it is only one favorable outcome, total 6 favorable outcomes. Therefore, 1 by 6. Now, what is probability that y less than equals to 4? Nothing but probability that getting y equals to 1 plus the probability that getting y equals to 4. So, 1 by 6 plus 1 by 6 is equals to 2 by 6. So, from this, what can you say that? P of x is less than equals to 2 is nothing but what? P of y is less than equals to y. So, this 1 is corresponding to 1 here, 2 is corresponding 4 here. Okay. So, it means what is, if you take in general, in place of 2, I am taking in general x value. Then, P of x is less than equals to x, nothing but what? P of y less than equals to y. Therefore, from this, what is the probability that y less than equals to y? Is nothing but the probability that x takes less than equals to x. Okay. Now, so what is P of x is less than equals to x? That is nothing but what? The distribution function of the random variable y. It means, what is the distribution function of the random variable y is equals to here fx of x. Fy of y is equals to what? Fx of x. Now, differentiate on both sides with respect to x, with respect to y, because you want the density function of the new random variable y. That's why differentiate both with respect to y. Then what do you get here? dfy of y by dy is equals to dfx of x by, okay, dfx of x by d, you are differentiate with respect to what? X. So with respect to y, you are differentiating. So when you are differentiating, what do you get? What is the relation between the distribution function and the density function? So what is fx of x is nothing but what? dfx of x by dx. The differentiation of the distribution function gives the density function. So here into what? dx by dy. You are differentiating with respect to what? With respect to y. Then how can I write down here? dfy of y by dy is equals to what? dfx of x by dy. I am writing 1 by dy is what? Into dx by dx. So if both these two are cancelled, then what do you get again? dfx of x by dy only. Now what is dfy of y dy? When you differentiate the distribution function with respect to, then what do you get? You are going to get the density function of what? The random variable y. So fy of y is equals to, now what is the differentiation of the distribution function of the random variable x with respect to x gives what? The density function of the random variable x into what you have here? dx by dy. Therefore, what is the density function of the new random variable or the transformed random variable y in the case of monotonically increasing transformation is equals to what? fx of x into dx by dy. What is y is equals to? T of x. So from this, what is x is equals to? T inverse of y. So from this, what can I write here? fx of T inverse of y into d. What is here? X is nothing but, by performing inverse operation, you are going to get. Is it right? By dy. So this is a density function of the transformed random variable y. What does it mean here? X equals T inverse y. For example, y equals to 2 into x. Then how do you get x equals to? Here we are multiplying. If I want the x in terms of y, you have to divide. So 1 by 2 of y. Nothing but what? Inverse operation. Therefore, what is the density function of the transformed random variable is equals to what? F y of y is equals to fx of x into dx by dy. Or else, what is x is nothing but? X is nothing but what? T inverse. Like what is x here? Nothing but T inverse of y into what? D by dy of T inverse of y. Okay, so this is a density function. Like that it can derive. In the same manner, I am going to derive the density function of the new transformed random variable y in case of what type of transformation? Monotonically decreasing. So what do you mean by monotonically decreasing? Here, a function is said to be monotonically decreasing if t of x1 is greater than t of x2, if x1 is less than x2. So what is here? Y is nothing but t of x. Then what is t of x1? This is any particular value of the random variable x is equals to what? y1. And what is y2 equals to t of x2. So what is the monotonically decreasing? y1 is greater than y2 if x1 is less than x2. It means as x is increasing, what about y is decreasing? Your x value is increasing. But what about the y value is decreasing? That's why it is called as what? Monotonically decreasing. Why it is called monotonic? Because you have a single value. Only one value is corresponding to a new random variable y. That's why it is called as what? Monotonic. Why it is called decreasing? As the transformed random variable y is increasing if x value is increasing. Y is decreasing as x is increasing. That's why it is called as what? Monotonically decreasing transformation. For example, I am taking two values. Let us say this is x1 and it is x2. What is the value of x1 corresponding to y? Nothing but here y1. And what is the the value of y corresponds to the random variable to the value x2 here, nothing but y2. Okay, if you observe the value, so y1 is greater than y2. So y1 is greater than y2. But what about x1? x1 is less than x2. That's why it is called as what? Monotonically decreasing transformation. So in the similar manner, how we derived the distribution density function for the monotonically increasing, we will derive for monotonically decreasing also. So what is the transfer random variable? Y is equals to t of x. Okay, then what type of transformation here? The transformation here, considering here monotonic transformation, and what type of nature it is? It is decreasing nature. So monotonically decreasing transformation. Then what is x equals to t inverse of y? Okay, for example, if y equals to 2 into x, then what is x equals to 1 by 2 of y? So it's nothing but what? It represents to y equals to t of x. By multiplying the x with 2, I am going to get y. How do I get x? Here multiplication is done. And here now to get the original value, how it should divide that? The transfer random variable with 2. Therefore, here multiplication, here division, nothing but inverse operation. By performing inverse operation in the transfer random variable, you are going to get the original random variable x. So that is the meaning of these two representations. Okay. Now, so what is the probability? What is the distribution function of the random variable y? Of the value to x y naught is equals to nothing but p of y less than equals to y naught. Nothing but the probability that random variable y is less than equals to y naught. In general, for any value, so how can you take here? Fy of y is equals to p of y less than equals to y naught. What is, sorry, not y naught, this is y. So what is small y? Nothing but maybe y naught, y1, y2. So it may be any value. In general, I am writing here. Okay. Now, so fy of y is nothing but what? P of y less than equals to y. Now, for example, I am taking the random variable x is equals to, let us say, 1, 2, 3, 4, 5, 6. Now, what I am doing here? I am performing the operation on the random variable x. Okay. So, what type of operation I am performing? Y equals to minus x. Just I am reversing the sign of the random variable x. Then what is my y equals to, or else I am taking y equals to minus 2 of x. Then what do you get here? Minus 2. 2 into minus nothing but minus 4, minus 6, minus 8, minus 10, minus 12. So what is the 1 is corresponding to the value minus 2. What is 2 is corresponding to the value minus 4. 3 is corresponding to the value minus 6. Then what is the probability that x equals to 1? Nothing but what? How many favorable outcomes here? 1. And total outcomes are here 6. Then nothing but 1 by 6. And what is the probability that x equals to 2? What are the favorable outcomes? Only 1. And total out of 6 outcomes. Therefore, 1 by 6. Then, what is the probability that x is less than equals to 2? Nothing but what? P of x equals to 1 plus P of x equals to 2. That equals to 1 by 6 plus 1 by 6 is equals to what? 2 by 6. Now, so I want to find out the probability that y. So now I want to find out the probability that y is less than equals to, let us say y is less than equals to minus 4. So it's nothing but what? Probability that y equals to minus 2 plus probability that, so y is less than equals to minus 4. What does it mean? Less than or equals to minus 4. Less than equals to minus 4, nothing but minus 4, minus 6, minus 8, minus 10, minus 12. Or else I am taking here less than equals to minus 8. For simplification, I am taking minus 8. Then what is the probability that y is less than equals to minus 8 is nothing but what? Probability that y takes y equals to minus 8 plus probability that y equals to minus 10 plus probability that y equals to minus 12. So what is the probability that y equals to minus 8? How many variable occurs? Only one. Out of total how many? 6. Therefore 1 by 6. Plus what is the probability that y equals to minus 10? 1 by 6. And what is the probability that y equals to minus 12? 1 by 6. Nothing but what? 3 by 6. Now I am taking here what is the probability that x is greater than or equals to, here I am taking y is less than or equals to minus 8. Minus 8 is represent to what? 4. So I am taking the probability that x is greater than or equals to 4 because minus 8 is corresponding to 4 and minus 10 is corresponding to 10 and minus 12 is corresponding to 6. Therefore, I have to take what? The probability that x is greater than or equals to 4, not less than or equals to 4. So, this is nothing but what? Probability that x equals to 4 because 4 is corresponding to y value minus 8 plus probability that x equals to 5. So, 5 is corresponding to the value minus 10 in the y plus x is equals to what? 6. Nothing but what? 1 by 6 plus 1 by 6 plus 1 by 6 is equals to 3. 3 by 6. What does it mean? These two are equal. It means what? See here. Probability of y is less than or equals to minus 8 is equals to what? Probability that x is less than or equals to 4. So, in general, what can you take? For any value, probability that y is less than or equals to y is equals to what? Probability that x is less than or equals to x. Now, what is the probability that y is less than or equals to y? Nothing but what? The distribution function f(y) of y. Now, from the properties of probability, what can you say that? The total probability, the probability of the event and its complementary event is equals to 1. Now, I am taking here, let us say a is x less than or equals to x. Then what is the probability that x is less than or equals to x? For example, a is x is less than or equals to x. And what is a bar? X is less than or equals to x. Then what is the probability that x is less than or equals to x? Nothing but 1 minus p of a. Nothing but x is less than or equals to x. So, here 1 minus p of x is less than or equals to x. That equals to 1 minus, what is the probability that the random variable x less than or equals to x? Nothing but the distribution function fx of x. So, here fy of y is equals to fx of x. So, this is a distribution function of the transform random variable in case of monotonic transformation. Now, I want to find out the density function. Then, how do you get the density function? By differentiating the distribution function, we get the density function. Therefore, dfy of y by dy. So, differentiating both sides with respect to what? Differentiate with respect to y because I want the density function of the new random variable y. So, dfy of y by equals to d by dy of 1 minus fx of x. So, what here? dfy of y by dy. What does it give? The distribution. The differentiation of the distribution gives the density function. Therefore, fy of y. This now represents what? The density function of the random variable y is equals to what? So, what is the differentiation of 1? It is a constant, therefore it is 0 minus differentiation of fx of x with respect to y. So, what does it give here? dfx of x by dy. That equals to minus dfx of x by, how I am writing here, multiply and divide with dx. So, dx by dy. That equals to what? So, what is the differentiation of the distribution function of the random variable x? It gives a density function of the random variable x. So, minus fx of x into dx by dy. That equals to what? fx of x into minus dx by dy. Therefore, this is a formula of density function for monotonically decreasing transformation. Or else, what is x is equals to T inverse of y. Then what is Fy of y is equals to Fx of x equals to T inverse y into minus d of what is x equals to T inverse of y by dy. So this is a formula to calculate the density function of the transformed random variable. Now in general, for a monotonic transformation, either it is increasing or decreasing, what can you write? Fy of y is equals to Fx of x into mod of dx by dy. If it is increasing, you'll get a positive sign. If it is decreasing, you're going to get a minus negative sign. Therefore, this is a monotonically increasing and decreasing transformation. So let us give an example on this. If x is a random variable, the probability density function Fx of x. Then find the probability density function of the random variable y equals to ax plus b. So what is y? So what is x? It is a given R, the original random variable. So this original random variable you are transforming into a new random variable y. How you are transforming? Multiply the random variable x with a and then add with a constant b, so that we are getting. So how you are getting y? Multiply the original random variable with a constant a and then add with b, so that you are getting the new random variable or transform random variable y. So what is y here? T of x. And what type of transformation is it? Monotonic or non-monotonic? For that, what do you do? So if you take any x value, for example, here I am taking x equals to some 1, 2. Then what is y equals to? A into 1 plus b, nothing but a plus b. And what is for value 2? 2a plus b, nothing but single value. There is a one-to-one correspondence. It is a linear equation. So it is a one-to-one correspondence. Therefore, here the type of transformation is what? Monotonic transformation. Is it increasing or decreasing? We don't know, because depending upon the value of a, it may be increase or decrease. That's why simply I am saying it is monotonic transformation. So for monotonic transformation, what is the density function of the transformed random variable y? Fy of y is equals to Fx of x equals to T inverse of y into mod of dx by dy. So this is a formula just now we have derived. So y equals to x plus b. From this, what is x equals to? So y minus b equals to ax. Then what is x equals to? 1 by a into y minus b. Therefore, what is x equals to? For any value, 1 by a into y minus b. So differentiate was with respect to y. Then what do you get here? So 1 by a into y. Differentiation of a constant is 0. That's why 1 by a. So what is differentiation of the x with respect to y is 1 by a. And what is x equals to? 1 by a into y minus b. Therefore, write down the density function here. Fy of y is equals to Fx of x is equals to T inverse y. So what is T inverse y? Nothing but 1 by a into y minus b into what? Mod of dx by dy. What is mod of dx by dy here? 1 by a. Like that, you can calculate the density function of the transformed random variable if you know the density function of the original random variable x. Let us see one more problem. If x is a random variable with an exponential probability density function of the form Fx of x is equals to 1 by 3 into e power minus x by 3 u of x. Now what I am doing here, I am transferring. What is my x? This is a original random variable. So what is y? Is it a transformed random variable? By performing operation on x, I am getting y. So what type of operation I am performing? Y equals to 2x plus 1. So by how I am getting y here? By multiplying x with 2 and then add with 1. So I am getting a new random variable y. Previously I have taken a and b. Here I have taken the values a, 2 and 1. So from this, what is x equals to? T inverse y. Nothing but what? Y minus 1 by 2. By performing. So bring this 1 here. Divide with 2. Here you are adding. Here you are subtracting. Here multiplying. Here you are dividing. That's it. Okay. So y minus 1 by 2. Now So what type of transformation it is? So the linear equation is corresponding to only single value. There is a one-to-one correspondence. If x equals to 1, so y equals to 2 into 1 plus nothing but 3. If x equals to minus 1, 2 into minus 1 minus 2 plus nothing but minus. It means there is a one-to-one correspondence. Therefore, the type of transformation here it is monotonic transformation. So depending upon this, you have to identify whether it is monotonic transformation or non-monotonic transformation. Then what is the density function? The transfer random variable fi of y is equals to fx of x equals to t inverse of y into mod of dx by dy. Here you can take, because x is increasing, y is also increasing. You can take a monotonically increasing. Or if you don't know, just write down the modulus. Okay. Then, so for any value of x, what is y equals, what is x value? Y minus 1 by 2. Then differentiate both with respect to y, then what do you get here? 1 by 2. Therefore, what is a density function of the transfer random variable fi of y equals to fx of x equals to t inverse of y. Nothing but in terms of y you have to write down. So y minus 1 by 2 into mod of dx by dy. What is mod of dx by dy? 1 by 2. But what they have given fx of x 1 by 3 into e power minus x3 even. So what they have given? So they have given that the density function of the random variable x is equals to 1 by 3 into e power minus x by 3 u of x. So e power minus x by 3 u of x. Now, so in place of x, what I have to substitute now? Y minus 1 by 2. So in place of x is substitute y minus 1 by 2. Then what can you obtain here? 1 by 3 into e power minus y minus 1 by 2 into u of y minus 1 by 2. Therefore, what is the density function of the new random variable fi of y equals to fx of x equals to y minus 1 by 2 and into mod of 1 by 2. So what can you obtain here? So 1 by 3 into e power minus 1 y minus 1 by 2 into u of y minus 1 by 2 into mod of 1 by 2. So like that you can calculate the density function of the transformed random variable if they give the density function of the original random variable x. Therefore, in the today's lecture, we have seen about the transformation of random variable. After that, we have seen the two types of transformation. They are monotonic and non-monotonic. Again, in the monotonic, you have seen the increasing, monotonically increasing and monotonically decreasing. And then we have derived the density function of monotonically transformed random variable. And then we have solved some problems on the topic monotonic transformation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.